Good day to you, Panther students, and welcome back to another algebra video tutorial on uh, polynomials and quadratics. We're going to expand upon what we've talked about regarding FOILing and using the box method and, just calculating the products of binomials altogether. So let's go ahead and warm up with the problem on the screen. Calculate the product of the following expression using the box method or by FOILing the binomials. Write your final answer in standard form. You may use whichever method you prefer, and then we'll go over it together. So go ahead and pause the video, give it a shot, and then we'll see if our answers match in the end. Cool. All right, I'm going to assume that you've tried it. I'm going to use the box method for the warm-up. And then for the examples that we do later on in the video, I will alternate back and forth between FOILing and the box method, just so that I address both techniques, or both methods rather. Okay, we'll start with the two variables. So the top left box. So y times y is y squared. We'll do the box beneath it. Negative 4 times y will be negative 4y. We'll then move to the top right box. So y times positive 2 is going to be positive 2y. And then our final box, negative 4 times positive 2 is going to be negative 8. And we write everything in standard form. So we're going to start with the term with the highest degree first. So the y squared gets to go first. Then we can put our two terms with the variable to the power of 1 in the middle. It does not matter which one comes first. And then we end, as always, with our constant. So let's go ahead and combine our like terms. Okay, we do have some like terms here in the middle. And when we combine those together, okay, that's going to give us, okay, we have opposite signs, so we subtract and keep the sign of the bigger number. 4 is bigger than 2, so we're going to keep the subtraction symbol. And 4 minus 2 is 2. So that's going to become negative 2y. And then we bring down the minus 8, and there we go. That is our final answer, and it is written in standard form. I'm going to sneeze, hold on. Okay. Hit the mute button just in time. Let's go ahead and quickly address what standard form is. Let's see, can I copy all of this? I'm sure I can. Let me get rid of that box. Do that. Oop. That's not what I wanted. Do that. Copy. And paste. Cool. All right, so this expression, okay, for our final answer is in the standard form for quadratic expressions. Okay, we have ax squared plus bx plus c. Okay, and remember, your variables can be, they can be letters other than x. Most of the time in these problems, the variable will be x, but it's good to have experience dealing with other letters. And these pluses can also be subtraction symbols. Okay, they can be minuses as well. Okay, so remember, a, b, and c represent the coefficients and the constant in our expression. So there's technically a 1 here in front of the y. So a is 1, b is negative 2, and then c is negative 8. Okay, this is in standard form. We'll come back to these x puzzles here in just a moment. But in the meantime, we are going to move to our new topic for the day, which is multiplying a difference of squares. Okay, and for the most part, this is going to be just doing more of the same Okay, it's using the box method, foiling, but there's going to be one new thing that happens in these problems. Okay, there's going to be one difference that you're going to see when we deal with these difference of squares. Okay, and here's the standard we're addressing at the bottom. And my goal for today, because I know that you guys can FOIL, I know that you guys can use the box method, but I want you to be able to explain, okay, what makes multiplying a difference of squares different from multiplying the binomials that we've done in the past. Okay, what makes the new thing that's going to happen? What causes it to happen? Okay, I would like for you to be able to explain that by the end of this video. Okay, so I want you to take a look at the two binomials that we have up here on the screen, and if I asked you to calculate the product of these two binomials, you would do exactly what you've done in all of these problems up to this point. Okay, you would FOIL, you would use the box method. Okay, you would multiply these together. Okay, but again, something different is going to happen. So if you look at the binomials on the screen, okay, you'll notice, okay, like the ones that we've done up to this point, okay, we have the same variable. Okay, and if you look at the constant in each binomial, okay, they're both 7s. Okay, so both of these binomials are almost exactly the same thing. Okay, but the main difference is that our signs for our constant are opposite. Okay, and that's going to make something unique happen in these problems. Okay, so the question that we're going to address is, what happens when our binomials contain two similar constants with opposite signs? Okay, see how we have similar constants but opposite signs? I would like for you to pause the video, multiply these together, and see if you can figure out what is going to happen in this problem that has not happened before in anything that we've dealt with. Okay, so I'm going to assume that you've tried it at this point, and let's see, I used the box method for the bell ringer, so that means I'll use the foiling method this time. Let me get it written on the screen. So F O, and maybe pink's not a good choice. F O I, and let's go with brown. Foil. Okay, so we start with the first term in each binomial, multiply those together. X times x, that's going to give us x squared. Moving to the O, the outer terms, okay, that's going to be x times -7, which gives us -7x. Okay, then we go to the I, which means that we are multiplying the innermost terms, so 7 times x will be positive 7x. And then as the name of the L implies, the last term in each binomial, so 7 times -7 gives us -49. Okay, so nothing new here so far until right now, when we combine our two terms with our variable to the power of 1. Combine those together, and what's going to happen? Well, it's the same thing that always happens when you combine two of the same term, but with opposite signs. -7 combined with +7 equals 0. Okay, so you'll end up with 0x, or they just cancel out entirely. So our terms to the power of 1 have canceled each other out, leaving us with just x squared minus 49. And there we go. That is the product of the two binomials that we foiled together. Okay, and this is technically still a quadratic. It's still in standard form. Remember, in order for a polynomial to be quadratic, you need your term that is to the power of 2, and that needs to be your leading term. Okay, there can't be any terms with an exponent greater than 2. Okay, there must be something to the power of 2, and that needs to be your highest degree in the expression. So this is the product of these two binomials multiplied together. Okay, let's do another one. Okay, I have the box already set up because we're going to use the box method for this one. So same thing, we have two binomials with similar constants, but those constants have opposite signs once again. Okay, they both have x's. We've got a -3 in our first binomial and a +3 in our second binomial. Okay, so once again, the only difference between these two is the sign of the constant. I'm going to write the first binomial. Each term is going to go on the left side of the box, right there. And the second binomial, each term is going to go above the box. So we have x there and +3 right here. And just like in the bell ringer, let's multiply these together. So x times x gives us x squared. And then, I'm kind of running out of colors here. -3 times positive x is going to give us -3x. Okay, in the top right box, x times +3 is +3x. And -3 times +3 gives us -9. Okay, and as you can see, when we combine our like terms, see here how we have a -3x and a +3x, the exact same thing that happened in example number 1 is going to take place again. Okay, both of our terms with the variable x to the power of 1 are going to cancel each other out because -3x combined with +3x gives you 0. So these cancel out, and that leaves us with a final answer of x to the power of 2 minus 9. Okay, and there we go. When you multiply a difference of squares, the term with the variable to the power of 1 always cancels itself out. Okay, and we can use our x puzzles to prove this. Okay, so this is an example of what we've been dealing with so far. Okay, and there's two different ways of writing this expression. Okay, x squared plus 0x minus 16. So this would be like this term right here, okay, if we wrote it as x squared plus 0x minus 9. Okay, if we wrote the 0x to the power of 1 after they'd cancel each other out, that's essentially what this expression at the top here in this pink box is. But that's not really the most proper way of writing it. Okay, you want to write your expressions in their most simplified form, okay, which would be the way this expression is written right here. Okay, these are two different ways of writing the same thing, but this version right here is considered the proper way of writing it, okay, because it is in its most simplified form. Okay, but when you're doing your x puzzles, it might actually help you to think of, it might actually help you if you think of it in this form. Okay, so think about it. If you were going to use an x puzzle to factor this trinomial, okay, like we did a few weeks ago, okay, remember, we need two numbers, okay, that multiply to make c, that add to make b. Okay, so two numbers that multiply to make negative 16. Let me write that down. Okay, that multiply to make negative 16, that add together to make 0. Well, those two numbers are going to be, that's going to be negative 4 and positive 4. Negative 4 times positive 4 is negative 16. Negative 4 plus positive 4 equals 0. So once you use your x puzzles, you'll see that we end up with a difference of squares. Okay, we can put plus 4 in the front and the minus 4 in the back. Okay, and it's just like what we've dealt with up to this point. Okay, two binomials that are almost identical, but again, the signs of the constants are opposite. Okay, and that's what leads to this 0x, okay, or the b term canceling out. So let's switch it up just a little bit, and this is going to be our final example of the video. And in the next video, we will be doing exactly what we did here. Okay, I'll give you the product of a difference of squares, and I will want you to work backwards to factor it and give me the binomial or the trinomial. Or I'm sorry, give me the two binomials that give you that final product. Okay, so what happens this time if our constants are exactly the same, but all of the variables, the variables are the ones that have the opposite signs? Okay, so as you can see, let's not use orange, let's stay color-coded. So you can see our constants this time are identical. Okay, they're both positive 11, but it's our variables this time that have the opposite signs. So negative x and positive x. Does the same thing happen? Well, let's find out. Let's find out if our term to the power of 1 cancels itself out again. And let's use the FOIL method. Okay, so we'll start with the firsts. Okay, so 11 times x is 11x. Okay, we'll then move to the outer, and that'll be 11 times 11, which is positive 121. We'll move to the inner. Negative x times x will be negative x squared. And finally, the last, the last, there we go. The last term. Negative x times positive 11 will be negative 11x. Now, because this first binomial was not written in its most proper form, okay, you can see the constant in this binomial here. The constant is in the front when it should be in the back. That means that our pieces of our answer here, okay, the terms are kind of shuffled and jumbled and out of order. So we're going to reshuffle these around so that it's in the proper order. Let's put the negative x squared in the front because it has the highest degree. We'll put both of our terms with our variable to the power of 1 in the middle. And we'll put our constant at the end where it belongs. There we go. And as you can see, when we combine our like terms, the same thing is going to happen that happened in the last two problems. We end up with negative x squared, positive 11x, and negative 11x cancel each other out. And we end up with a constant of 121. And there we go. So if the constants are the same and your variables have opposite signs, the exact same thing happens. Okay, the terms to the power of 1 cancel each other out. So, not a whole lot of new content in this video, but multiplying a difference of squares is something that you want to get used to because we are going to be dealing with what we call perfect squares in quadratics. Okay, we've dealt with perfect squares in the forms of whole numbers, but we have yet to talk about full expressions that are quadratic and are also perfect squares in and of themselves, and that's what we'll be focusing on in the near future. So if you're in my Google Classroom, you're gonna find two assignments that are assigned to you. One is the introductory assignment to multiplying a difference of squares, and then the next is multiplying a difference of squares, but the problems are just a little bit more complex. Okay, you'll be dealing with two-digit numbers. Your leading terms may have coefficients, but they're both the exact same thing. Okay, FOIL. Use the box method, cancel out what you can, and then just write your answer, your final answer in standard form. If you have questions, please leave them in Google Classroom because I get the notifications for Google Classroom a lot quicker than I do notifications on YouTube. I don't know why that is, but if you want to post on YouTube, that's okay. If you want to email me directly, that is also fine. But go ahead and give it a shot, and let me know if you have questions. All right, you guys, take care.